In heating, ventilation, and air conditioning, the atmospheric air plays an important role for the heat exchange. Therefore, first we need to study the properties of air and how the changes desired for air conditioning are achieved in this. As we are moving into the HVAC, the first important thing to study is the air and water vapor mixture and interaction of both. So the science which deals with the study of air and water vapor mixture is called as the psychrometrics. In psychrometrics, we study the various thermodynamic properties and processes associated with air and water vapor mixture. So in this psychrometrics, the first thing that we are going to study some basic definitions, basic parameters to define properties of air, and then psychrometric chart, and then processes that will study only basic process initially in psychrometric chart. So, as we know that air is a mixture of various gases. For example, nitrogen plus carbon dioxide plus oxygen plus argon and other gases. Plus, it is also consist of water vapor. But in any air, if we call, this component remains, or this composition remains constant, whereas this composition of water vapor changes with respect to temperature. Therefore, the air which is consists of the water vapor plus other gases. So this part we will call it as dry air, and the water vapor we will study with respect to the composition of dry air. So in the next uh, wherever we are using the air, it will have two parts, that is dry air and water vapor. So generally any air, for the sake we will now use it as only dry air for our study purpose. This range of temperature varies from generally roughly from -5 degrees centigrade to 50 centigrade, and in this range we can treat this air as an ideal gas. Similarly, for the case of water vapor, we will also treat this as ideal gas for our study. If you refer to the TS diagram of water in this case, we will see that the enthalpy becomes constant roughly around 50 degrees centigrade. This is the H constant line. Therefore, H is directly proportional to T in this case in the range that we are going to study in this psychrometrics. I've described that air has two components. One is this dry air and other is this water vapor or moisture in dry air. Therefore, in this range that we are going to refer, the both are going to behave as an ideal gas. Then we know from the Dalton's pressure law that total pressure of air will be equals to PA plus PV. So here onward, this uh, A suffix to the P will be the indication of dry air, and this PV will be the pressure of water vapor in all the subsequent cases. Now, we have to now determine that for our sake of study, how much water vapor is there in total air. This is the our study. Therefore, we determine this by absolute humidity. So if we determine absolute humidity as the ratio of mass of vapor to the mass of dry air. So this is what called as the absolute humidity or specific humidity or humidity ratio. Therefore, omega, we denote this absolute humidity by omega. So this is mv by ma. So applying this mv can be written as PV volume divided by RV T divided by P of A dry air, V RA and this T. Therefore, volume V will remain constant for both cases. Therefore, this can be written as PV into RA divided by PA into RV. This is further simplified as PV. This is R universal gas constant divided by this mass of air, this PAR divided by mass of air. Therefore, this will come as 0.622 PV divided by PA. So this absolute humidity omega is given by 0.622 PV. Now this PA is equals to P total air pressure that we denote by P minus PV. So for all the calculation and determining the absolute humidity, we will use this omega as the this formula of absolute humidity for our calculation. Now, what happens in the case of air, that suppose this is dry air and some component of water vapor is present. Now, if we keep adding in this water vapor through some mechanism, then at some point what will happen, the air will become saturated. And to measure this further saturation, the concept of relative humidity is in use. With this, denote this relative humidity by phi. So the definition of relative humidity says that it is the ratio of mass of water vapor to the mass of water vapor at saturated condition. However, to be noted, one thing in this that the temperature will remain the same.